Alright, so today we're going to do a little applications of inverse trig functions and the graphs and all that good stuff. So if you'll take a second and work through the front page for me. So 137 right here. See if you can do this without me. Pause the video and then come back to it for your answers. Okay, so the temperature in Fahrenheit outside a house during a 24-hour period is given by the function f of t is equal to 80 minus 10 cosine of pi times t over 12. Okay, and so that's for 0 to 24 for time. Time is measured in hours, so note all angle measures are in radians. Okay, so find the temperature at t equals 0. So what am I going to do? I'm going to plug 0 in for my t. So I have 80 minus 10 cosine of 0, right? So that's going to be what? 1. So 80 minus 10 is 70. So, and this is in degrees Fahrenheit. Okay. F of 12. I'm going to plug in a 12. So 80 minus 10. And then cosine of, if I plug a 12 in there, that'll be pi times 12 over 12, which is just going to be a pi. So it's a negative 1. So cosine of pi is a negative 1. Negative 1 times 10, or negative 10 is a positive 10. So that's a negative, or that's a 90 degrees Fahrenheit. And 24. So f of 24. So we'll say 80 minus 10 times cosine of, so that's going to be what, a 2 pi? So that's 80 minus 10 cosine of 2 pi, which is back to 1. So that's 70. So it's periodic here, so we are going to just start repeating because we are looking at a trig function, right? Okay. What is the highest temperature recorded outside the house? And how do I know? So what is it going to be? So it's going to be 90 degrees. And how I know is my 80 is my what? Vertical shift. And then 10 right there is an amplitude, right? So 10 is that amplitude. So it's going to stretch it. So cosine, remember, cosine usually goes from negative 1 to 1, right? But the amplitude being a 10 means it's going to stretch that to 10 and negative 10. But that 80 vertical shift means that it's going to shift it all the way up to 80. So when I shift it up to 80, that means that 90 will be my top and 70 will be my bottom. Right, what would it make sense for t equals 0 to represent midnight? Why or why not? T equals 0 is going to be 70 degrees. So, what do you think? Probably not. I mean, it could, but probably not. Usually your minimum temperature is roughly around 2 or 3 a.m. So usually about 3 a.m. is when your minimum temperature is. Okay, so let's sketch this graph. So we kind of already talked about all of that right here. So on the x-axis right here, this is t in hours, right? So this is hours. And then this is, oops, I don't know what that is. But that is my Fahrenheit, so that is degrees Fahrenheit. Okay. All right, so we've moved my midline up to 80. Right, so we're shifted up to 80. At 0, we are at 70. Okay. At 12, we were at, what, 90? And then at 24, we're back down to 70. So probably about right here, roughly about right there. So remember periodic, so this is going to keep going through my next 24-hour period. So think about that. So one full rotation of my graph, so one period of this graph is 2 pi divided by b, and my b in my case is pi over 12. So that's what 2 pi times 12 over pi. So my period is going to be 24 hours. So I did graph that right. Okay. All right, what about number 5? It says find the amplitude of f of t. So we already kind of talked about that. Amplitude is going to be 10. Explain what your answer means in the context of this problem. So what's happening? So, sorry. So the amplitude is 10. So basically it's going to fluctuate 10 units, so 10 degrees, right? So the average shift in temperature from the middle line, and in this case it'll be roughly your median, right? Your middle line. Okay, so let's look here. Imagine if we use this model to predict the temperature over a 48-hour period. Describe what the model predicts would happen on day 2. So the hours between 24 to 48. So what do you think is going to happen? So it's going to match over here, right? So it's going to be the same model right here. So it would match the 0 to, but just shifted down, right? So it would match from 0 to 24. So, I would think it's reasonable, like, depending on where I am, what period, like, what time I'm looking for. So, like, summer, maybe, probably, because summer is pretty much predictable from day to day, but everything else, probably not. Okay, so the air conditioner turns on when the temperature is at or above 78 degrees. At what time T does the air conditioner turn on, and when does it shut off again? Okay, so what am I going to do to solve this? I want to set my equation equal to 78. So I'll say 78 is going to be equal to 80 minus 10 cosine of pi t over 12. And so now I want to solve for t inside there. So just like a little linear equation here, I'm going to move my 80 over here. So I'm going to subtract 80. So I get, what, a negative 2. Then I'll divide by negative 10. So negative 2 divided by negative 10 is what, 1/5? So how do I get the t on the outside? So to get the t outside of the function, the only way I can do that is to take the inverse trig function. So the inverse trig function there. Okay. I don't know this value, so I'm going to have to use my calculator to calculate this. Make sure that we're in radians, because inside here we've got pi over 12. So inverse cosine of 1 over 5 is what? So I think I got 1.37. And then this goes away, so I'm left with pi t over 12. And so now you need to solve for t. So t is roughly, what? 1.37 times 12 all over a pi. So that's what, 5.12 or 5.2. So periodic, so this is when the air conditioner turns on, and if it turns off, it'll be in a 24-hour period here, right? So I'll say 24 minus 5.2. So it'll turn off at 18.8 hours. All right. Trig modeling here. So Trig modeling here, we have periodic behavior. That repeats. In a fixed manner. So when you have a periodic behavior that repeats itself, so it can be modeled with a trig function. So the period represents the time for one cycle so like a Ferris wheel problem is a periodic behavior because I keep going around and around and around like the Ferris wheel. Midline is the average value. And then your average plus your amplitude is your max. And the average minus your amplitude is your minimum value. Okay. All right, so take a second and see if you can understand kind of what we did. So try these 5 problems for me. So pause the video and try these for me. Alright, so Patty decides to ride the Ferris wheel at the amusement park. Her distance above the ground and feet after t seconds is given by y of t equals negative 20 cosine pi t over 4 plus 23. Explain why it makes sense that her distance is modeled by a trig function. So, kind of give this one away. Ferris wheel is a circle. And I go around and around and around and around. And the motion here is periodic. So think about, I'm trying to draw a Ferris wheel over here. That's terrible, I'm sorry, but you know, we're at the same distance above the ground and you can keep going around and around and around and around that Ferris wheel. So estimate her height above the ground after 5.5 seconds. So we'll say y of 5.5. So we'll say negative 20 cosine of pi. So I'm going to have to use my calculator for sure for this because I don't know that in my head. So cosine, make sure you're in radio mode. So cosine of 5.5 pi over 4 times negative 20 plus 23. So that's going to give me what, 30.65? What is the maximum height of Patty is ever off the ground? What is the minimum height? So my midline is 23. So 23 is my midline. And 20 is my amp. Right there. So 20 right there represents my amp. So 23 plus 20. So that's 43. So that is my max. And my mid is 23 minus 20, which is 3 feet. I guess I need to put feet, I'm sorry. Is my min. So this can't be 0 because remember, and see how I drew it right here. So when you get on, it can't be touching the ground, right? So it can't touch the ground. Ferris wheel, you got to be off the ground a little bit to be able to start. Okay. All right, number 4, what is the diameter of the Ferris wheel and how do I know? So the diameter is going to be, what, 40? So my max minus my min. And it's also, what, twice my radius there, right? So 2 times my radius. And then how long does it take the Ferris wheel to make one complete revolution? So that's going to be my period. So I'll take 2 pi and divide that by pi over 4. So it's going to take, what, 8 pi over pi, which will be 8. And we are in, our time is in seconds, so it's 8 seconds. Okay. All right, let me know if you have any questions about these application problems.